In the last couple of videos, I introduced you to a REPL, and we get to play around with several different languages. And I encourage you to keep practicing and familiarizing yourselves with these different languages and just how they work and the syntax. If you want to be a writer, you write. That's the best advice I can give you. But I feel like if I don't give you more of a general picture of what's going on, a sort of bird's eye view of the entire ecosystem of programming, then I'll start to do you a disservice. So what I'm going to do here is basically go over all the different languages, not all of them, but I'm going to give you a reason for why there are actual, different programming languages. Why even have multiple ones, and what's their purposes, and see where you might fit in to all of this. So this right here is a graph that shows the popularity of many different programming languages over time, and I believe this graph goes all the way back to 2014. And as you can see, JavaScript here has been number one for a long time. I didn't even realize, but apparently in the last quarter of last year of 2021, Python is starting to overtake it, which I think is pretty cool. Now these are used for generally two different things, and that's something I've touched on a little bit, but it might be good to go over this now. So well, for instance, there are many different kinds of languages, and not all languages are considered programming languages. Like, for instance, this language down here, this is called SCSS, also sometimes called SAS. It is a templating language, and it's basically a cleaner version of, do they not have CSS in here? I guess they don't, or maybe I'm blind and can't see it. But this is a templating language based on something called CSS, and it's used to bring color to pages. All the colors in this page are either using, well, they're all using CSS, but SCSS can get compiled down into CSS. So that's another aspect to this. Some languages are closer to CPU than others, and I've said that before. What that means in practice is that the computer is only going to read binary, so you have to have a process of getting your code back into binary. Languages like C and C++ are pretty close to binary, and then a lot of other languages actually get compiled back into C++, like Python and Ruby, for instance. I think they get compiled back into C++ and then get compiled into binary. So you have some that read more like English, like Ruby, which reads very much like English, and then some that read a little bit closer to machine code, like C++, although it's not entirely machine code. It's definitely not English, but it's not like ones and zeros. So what that means, like in practice, is like, for instance, game developers often learn C++ because it's a lot faster. Now, Ruby can do just about everything C++ can, but because it's been abstracted away from machine code, just a little bit more to be more like English, it's going to be slower. There's going to have to be several more processes from going from Ruby getting back to binary. So it's going to be a little bit slower. So you could build a video game in Ruby, but you're probably going to experience some lag. And that's why a lot of times game developers, they'll stick in C++. I know Java is also a big one. Java was Minecraft. If you ever played Minecraft, that's all written in Java. And these languages are a little bit faster. There's no real solutions here in terms of, like, there's no solutions, there's only trade-offs, right? Like, there's no one language that's better than another. It's more of just trade-offs, and each one of these languages were originally designed to solve a purpose, to solve a problem. Otherwise, they never would have built them to begin with. And so each language does something a little bit better than other ones do. So, for instance, like Python is very good when dealing with data. Whenever I deal with a project that has a lot of data and basically more of a data analysis project, man, I love Python. I would never use JavaScript for that because math and JavaScript's just not as full scoped as Python is. In Python, you can make a graph come up in just a few lines of code, and it's incredible. It's a lot of fun. Now, JavaScript is used in the browser, It's actually considered a front-end language because it often runs in the browser. Now, through Node.js, they have basically allowed it to work on the back end nowadays, but JavaScript primarily runs in the browser, which means this thing right here, this browser that we have, it runs in your Google Chrome, your Microsoft Edge. That's where it's running. PHP is a server-side language, so it's going to be in the server side, and that's another paradigm to this. You tend to have languages that are closer to the front end, mean closer to the end user, like in the browser, for instance. Then you have other languages that are closer to the server, like for instance PHP, which is it runs on the back end of the website, right? And then Python, you can make a website in Python, but that tends to be more of just a back-end programming language, like I want to do a bunch of math or build an AI or something like that. And once again, you could do anything with any of these languages. If I wanted to build an AI in Ruby, I totally could. It might be a little bit slower than the Python, and it would definitely be a little bit slower than the C++, but I could do it. I could totally do it. Now, CSS, I couldn't do that because CSS is not considered a programming language. It's a templating language. It has a very, very specific purpose. And so there's some differences there. I want to show you something I found. Let's start with this one. So this is saying hello world in 53 different languages. And I just want to show you sort of the different syntax you might find and sort of the trade-offs you might see here. So this is in C. This is how you would say hello world, just right here. You get to make this sort of function. Very similar to C++. C Sharp's just another sort of version of C. Now let's see what it looks like in, for instance, Python. One line. That's all it takes. R. One line. All it takes. Some of these newer languages, just one line. Ruby. One line. Rust, I think, is a server language. Intended to replace languages like C for doing systems level work. Yeah. Some of these more back-end languages, they get more complex. Swift, that's what iPhone apps use. One line. TypeScript's like a fancy JavaScript. One line. PHP can also be done in one line. Machine code. Yeah, you're probably not writing that. So yeah, so there's basically just trade-offs here. You have different purposes for whichever thing you find yourself wanting to do. You're going to want to decide, well, what language best fits that purpose, and that's one of the reasons why I'm trying to drill it into, at least you guys, is that if you try to pigeonhole yourself in one language, you might not get very far because you might come across a problem that, well, the language that you've learned, all your life or whatever, might not be the best one for the job, and you might just be wasting your time. I think it's much better to be pragmatic, to learn pragmatically, to understand that you're not going to learn everything. You will not be able to learn every single language. There's just, at this point, the internet is in its entirety cannot be understood by one person. And so you need to be pragmatic in the things you learn. And what I want to try to do in this course is to basically, I want to teach you this in the same way that I would teach somebody how to ride a bike. I think in a lot of these courses they're going to go through and it'll be more like an academic feel. And one thing I've seen about academia, it's like, okay, you're trying to teach somebody how to ride a bike. Imagine trying to teach somebody how to ride a bike going through schooling. This is the best analogy I've ever heard. It's like, okay, first you're going to sit in a class and learn about the theory of biking and the different approaches to biking and all these other things. And then you ask, hey, can I ride a bike? And they're like, no, you have to go through 2 or 3 more years of learning about all the different theories of biking. And, it's ridiculous. Just get on the bike, right? Just get on the bike and just start learning. best thing you can do, honestly. And just be pragmatic in it. Understand that you are not going to learn everything. Learn the things you need to know. Learn things just in time. That's the best approach. All right. That covers this video. I'll see you in the next one.